panel discussion that is on emerging technologies exploring blockchain, Internet of Things, and quantum computing. So to start that, I would like to call upon on the stage the moderator, that is Commander Suman Kumar Chakraborty, to start with. He is the head customer success canvas at LTIMindtree. Next we have Mukesh Jain, CTO, VP and global head of public analytics, Capgemini. Mr. Mukesh Jain. He is not present? Okay. We have Richa Daga, software engineer, Cisco. Ishan Shivansh Bangroo, senior developer, AI, Megasoft Sol. And we have Anurag Agrawal, CEO, co-founder and director, DataBloc Technologies. Over to you, sir. Suman, sir.
Good evening. So I think end of the day, last panel, the second last, I've been cued by her. So before we get there, in fact, when the name was called out, it was a draw of lots. And I came to know that it's been me who is the moderator as well. So please welcome all of you again on behalf of the panel. Before we go to the self-introduction round, I'll only say that this emerging technologies, which is the topic of our discussion today, talks about exploring three technologies of blockchain, IoT, and quantum computing. So before, like I said, let me start by a joke on itself. And I'll try to curate, I just pulled out a few seconds back, how will I introduce these topics? First, the closest to my heart is blockchain. All of us who know about blockchain are sure that the origin is someone who chose to be anonymous. That's blockchain for you. They say that second joke, let's talk about IoT. The S in the IoT stands for security. Disclaimer, there is no S. And the third, why to leave quantum computing behind? If I tell you a joke on quantum computing, you either understand it or you don't. But in quantum computing, it is neither nor. So there's no point telling a quantum computing joke, is it? So I think I have your attention, all of you. So let's start from the start. As in, I'll like to quote Aristotle when he said, and I quote, that it is always that the whole is greater than the sum of its parts. How is that relevant in this topic? When we see these three technologies and we hear from these speakers, we'll understand. So first, let's have an intro of the speakers, then come back to reckon why did I say so when I said what Aristotle did. Richa, over to you.
Yeah, thank you, Suman, for giving a very nice introduction to all the three technologies that we will be talking about. So thanks a lot for that. Hello, everyone. I'm Richa Daga. I'm a software lead at Cisco, and I work in the development of products that I proudly say, that are pioneering the breakthroughs to build the internet of the future. So apart from that, I'm a global technical speaker and an international best-selling author. My author journey started with because I'm passionate about the cause of diversity and inclusion, and I was selected to author an anthology of 20 inspiring women across the globe. So that's how I became an author for the first time, and that journey is continuing. Apart from that, I'm also a speaker at IoT community conferences. That is the world's largest community of IoT practitioners in the whole world. And I'm also serving as the India leader of Cisco Women in Science and Engineering. The abbreviation, we call it as WISE. So that is to promote the budding engineers, the women engineers that are in their colleges, and also the bright minds that are in schools. So I'm passionate about technology and also about the cause of women in tech. So now I'll be moving over to our next esteemed speaker for the day.
Hey everyone, it's Ishan in here. So I'm presently playing the role of senior AI developer at Megasoft. Apart from that, I'm also a part of Royal Society of Biology in London. and Royal Society of Chemistry as well. And alongside that, I'm also like playing the role of a member at IEEE. With all of this in hand, like I have graduated from UF, and there I have been into AI. And I'm thinking to skip into quantum computing because like we have got quantum annealing, which is much faster, much enhanced than our regular structures. Let's pass on to our next speaker.
Hi, good evening, everyone. Before I give my introduction, Mitali, I was telling Ishan that we need to have an award for the best dressed person in the room, right? So, okay, see, good evening, everyone. My name is Anurag Agrawal. I'm the co-founder and director of DataBloc Technologies, working in blockchain and Web3 space. I've been running my own company for the last 6 years. Otherwise, I've been a veteran of IT industry for 25 plus years. Thank you.
Yeah, hello. So that's, I think I am left to introduce myself. The only thing I will add, because I've been introduced I think more than twice now, is I am head customer success for Canvas. Canvas is an AI/ML platform for LTIMindtree, and that is how it is coming, because it doesn't make sense when you read it through. Head of customer success Canvas, as in, is the customer success or is it the Canvas? So that's where I am, Commander Suman Chakraborty. Been with the Navy for 21 years. Last 3 years out on the Civil Street. Couple of startups as head of technology, and with LTIMindtree to incubate first their Web3, and now, like I said, with this AI/ML product. So yes, now getting back to the topic, because that's where we left at, Aristotle. So let me time box for you to get an assessment of why we are still keen on calling these technologies emerging. The whole of the beginning of 20th century, we saw people contributing to quantum computing. Let's start with that first. I'm trying to time box here. 1922, he gets a Nobel Prize. Talks about the Bose model. But not before 1984 is that quantum computing per se came to foray. The father there was talking about David Deutsch from Oxford. 10 years later, 1994, we have Kevin Ashton speak about IoT now. If we go further into the timelines, and 2008, we had this anonymous person I spoke about, Satoshi Nakamoto, gave us the Bitcoin paper, which is the basis of blockchain. He talks about the double spending problem. And then we had what to do with blockchain is to execute it. Came in 2015 when we had Vitalik Buterin give us the smart contracts and Ethereum per se. So what are these dates I'm throwing around, trying to do? All of us are techies first over here, and we'll acknowledge the fact that if we talk about the S curves, which is the innovation curves or the adoption of technology curves, there is an inception and they go right up to the part that there is a plateau of productivity, also gets mentioned in hype cycle. 3 decades, 2 decades, 1 decade plus, and yet we are emerging. Why so? What has bound these 3 technologies, if I may say that? We've been hearing this word, the most spoken word today since morning is data. Data is a new fuel, we all agree to that. But data, with data, when we talk about data, it's about the integrity of it. It's the provenance, the origin of it. It's the optimization. But we will all also agree with data and the DBMS someone was mentioning there, and we're talking about all kind of DBMS over here, comes an inherent trade-off. That stops me to quote Cap's theorem, which is the Brewer's theorem, which talks about if there's a triangle and there are 3 vertices, you can only get 2 at a time. Consistency of data I've just shared, the availability of the input-output functions, and the tolerance, which is the partition tolerance. How many messages you will miss still to make sense of it. In fact, it was elucidated even better by Vitalik Buterin when he talked about the blockchain trilemma. The blockchain trilemma, again, is a very curious case. Here is very open, and this trilemma is actually not only for blockchain. When I say this, it's agnostic. It's for all these 3 technologies we're talking about. The blockchain trilemma says that 3 things, again, very important, which is security, decentralization, and scalability All three are again the vertices of a triangle. And therefore, this one straight line you can draw at most covers two of them. Let me dwell on this a little further so that it's akin to all of you. Now, the trilemma, I will take the scaling part. When I talk about scalability and blockchain, let's understand that what are we talking about? Talking about transactions per second. And these transactions per second of the public blockchain, if you just kind of quote unquote, stands for Bitcoin at 7, Ethereum at 30. It goes upwards. People will start quoting Solana as well. I'll keep it to the public blockchains over here, not layer 1, layer 2. So we're talking about transactions per second compared to Visa and PayPal, which are 60,000 plus. So that is the scalability difference between when you talk about blockchain transactions vis-a-vis a transaction we are used to. Yes, we have UPI today as well, 2,500 transactions per second, but I'm not getting there. The gold standards are Visa and PayPal. Scalability, one part of the vertex. The other part, like I said, the joke about IoT, the S in the IoT, is security. We have 20 billion IoT devices today. I didn't count and come in. It's just a matter of fact being told and being quoted everywhere. I too, quote unquote, 20 billion of them. All of them are pointing out to what it can do, which is exposure to this. It's the malware to the ransomware of sorts. Similarly, the problem with decentralization, when we talk about decentralization, at what cost? So these three can never be mitigated alone. While there are the layer 1 and layer 2 coming in, there are a lot of effort being done. But come quantum computing, or come quantum resistant ledger, Bitcoin post-quantum, two public blockchains in the reality. I'm not talking about quantum as in tomorrow, quantum as in today. These will take care of the smart contracts being quantum resistant. And therefore, the scalability and the processing power can be taken care of. The security which we're talking about, so much so with IoT, can be taken care by blockchain and combination of quantum key, I would say, exchange. Simply put, if you and me listen, third person eavesdrop, our verification fails. Come to know instantly. And that's decentralized, because on blockchain. What I'm trying to say, while each of them couldn't have come out of the trilemma, it is this interdisciplinary part, which is maybe the first part of my discourse, is to explain that individually they did not cross the chasm. Crossing the chasm, most of us have read that book. It talks about Jeffrey Moore speaking about crossing the chasm when it talks about technology. What is this chasm? This chasm is of hyperproductivity. As in, you come for inception in a technology to be economically viable. So dare me, but I say so, that you haven't had the eureka moment for these three technologies individually, despite these decades of work. Or if I say today's context, there hasn't been a chat GPT moment yet. Having said that, I've just spoken about the CAP theorem, talking about the blockchain trilemma. What can they do? I just explained. Let me take a step further. Take a point in its case and a problem statement. Post-COVID, the problem has definitely been for us the supply chain. Just to quote Capgemini report, 75% of the people in supply chain do not know that there's a lack of visibility, which is the reason why today the supply chain is at 2x inefficiencies vis-a-vis what used to be prior COVID. What I'm trying to get at, if the problem statement is supply chain, now we have a solution of visibility through blockchain. But when blockchain comes into alone as a standalone solution, it doesn't suffice. Because what suffices is the IoT. Because I mentioned COVID, let me also mention vaccine. And let me mention vaccine ledger. It's one of the startups I was closely working with. It's a digital public good out in the domain. And what it did was collect these IoT sensor data and this RFID, parent-child relationship, and made a digital twin. And once you start embedding that information on a blockchain, it becomes tamper-proof. So what I'm trying to say, their synergies are working, they're feeding into each other. And when, like I mentioned, if you have a quantum-resistant smart contract, you're executing at those speeds. Smart contract is about execution of blockchain. I'll leave the later part to my esteemed panelists to explain more during his discourse. So what I'm trying to say, the problem statement was supply chain. We had these three technologies now feeding into each other and cascading of the S-curves to bring it out of it. The second part, which is, or a second point in case, is what we are used to is the internet. So internet will be democratized, was what Web3 came in with. Internet will be secured and democratized when we talk about quantum computing and how the quantum key, like I explained, exchange can happen. So actually with these 20 billion IoT devices or edge devices, we are going to, in the future, where we can claim to have a persistent, always available, democratized internet. So these two were, I would say, specific point in case I wanted to discuss as problem statement, where these three can synergize as interdisciplinary and bring you out of these problems as a solution. Second part I would like to touch before I give it to Richa, and she speaks more about IoT, because she's a specialist there, is the India story. The day started today with our chief guest speaking about India initiatives. Amazing. In fact, there are many things which he made me tick off what I'm going to speak to now. So let me talk about what is left out of it. First and foremost, if we talk about the NASSCOM report of last year, it's simple. 11% of the total blockchain and the Web3 workforce are Indians last year, growing at 120% to reach, by 2025, 1/3 of the global blockchain workforce. We are 75,000 as on date. It's only increasing. NASSCOM report. Let's talk about quantum computing. Quantum computing, we are all aware of the D-Wave, right? That's one of the pioneers. They have a program called LEAP, which measures how many contributors are, because it's like a crowd platform. It's an open cloud and crowd both, as in crowd sourcing and cloud computing through quantum, seeing the projects that you're doing. 1/3 of the contributors in D-Wave are Indians. 43% of the world IoT market are with Indians. LTTS, DIGITALConfex, you name it. What I'm trying to get at, that you have not only the mind share, you have the market share as well in these three technologies in this country. And then we have what Mr. Patnaik was bringing out, those guardrails of the government, solving a very pertinent problem. I call that problem sunrise problem. And why is that a sunrise problem? What I send from here as a transaction cross-border doesn't get accepted there. And what he sends from there, so if we do not have policies which are universal, we will always have a sunrise problem. And to make it, these transactions, consensus mechanism to be such that everyone agrees to it, we need what a country is doing to G20 or to IMF, which is asking for global consensus. So that, be it our UPI, be it our any supply chain issues, get mitigated at large. And lastly, let me also mention that what this, as a mission we are on. Of these three technologies, quantum is a mission for this country, which came in 2020. 8 billion INR invested as budget given for 2020-2025. We had the accommodation of the IITM, Madras, joining with IBM, with a global network of 180 more MNCs. So those are the kind of imperatives that this government is doing with the demographic advantage we already have. Let's not even get to Scale India. Let's not even get to smart cities, because that's what Richa is going to speak about. Just the demographic advantage we have of being the leaders in the curve, and the fact that the government are doing this course corrections so that we don't have a sunrise problem. Quist, I will leave it at that. Quist, Q-I-S-T, is one of the open source kit of quantum computing in 3 languages, Tamil, Bengali, and Hindi. Such is the adoption which is happening. So with that, I call in Richa. So what are her views on IoT, on smart cities, smart grid, and likewise. Richa.
Yeah, thank you, Suman, for elaborating on the 3 technologies. And as you rightly mentioned about the visibility part, so that caught my eye, because I thought you were mentioning about visibility that has something to do with IoT, and then in the next sentence you said that IoT is the key point for visibility. So yes, so as you rightly mentioned about the initiatives by the government, and this is something we all know. We keep hearing about smart cities, but it's not just only about smart cities. There are a lot of smarter things working in the background to make our cities smart. And IoT is easy to remember. Whenever you will hear a word prefix smart, that is IoT. So anything that I'm going to say about smart cities, smart infrastructure, smart networks, smart cars, connected transportation, everything is IoT. So it's easy to remember in that sense. And if I continue about like what we are mostly close to, like smart homes, I would like to say, if you would just think about that you have your connected appliances at home, or these connected lights, that there are sensors, you enter the room and the lights go on, that is a very minuscule use of IoT. That is a user IoT that we are using at homes. But now IoT has paved our way to become from passive consumers to like active consumers. Because when you are at your home and you're talking about these smart devices, they connect to the electricity grids. So now we have even moved from traditional electricity grids to smart grids. And as I was already saying, smart is the word everywhere, so bear with me when I will keep on using smart. So the move from traditional electricity grids to smart grids has made us active users of electricity, and we can actually help us monitor our electricity usage. So suppose if you have to run something like your, even a small example of a washing machine, or you have to charge your electric car, then you can ensure whenever would be the lightest load on the grid, at that time you can let your appliance get charged or use the most electricity out of the grid. And that you can only do when you know what is the electricity usage. So earlier we only had a one-way communication between our smart homes and traditional electricity grids, but now we are having a two-way communication. We are having smart meters. So that enables us to become active users, and we can make use and even earn, because we would be contributing to the electricity grid in a manner that, suppose another example that I can take, if we talk about, like everyone would have heard about electric vehicles. So what we know that, of course, we will save on fuel, that is going to happen, but you still have to charge it. So you'll be spending money on charging an electrical vehicle. But the government and the initiatives are such that if you are using your vehicle, it has charging stored in it, and now you're not going to use it for another half of the day or for or tomorrow. Then there's a technology such as vehicle to load. You can actually transfer the electricity from your car to the electricity grid and earn from it, because you help the electricity grid to manage the loads around. So that's another aspect of electricity grids that I was talking about. But there is just one part. If you are, like all of us are interested in driving, we talk about autonomous cars, that when they will be becoming a reality in India. Autonomous cars, again, they have an aspect of IoT that are helping us to enable it because of the sensors. The sensors around are helping us that to cause of any accidents that can happen. Because all of the data to the sensors which can be collected can go over, some analytics can be running over it. And of course, the magic word data, as it is being used all over the day, and as Suman even mentioned, you talk about IoT, you talk about sensors, data, 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 everywhere data. So you have the data, now you have to run analytics over it. And for that analytics, we have our esteemed panelists talking about AI or ML. Those will come on the later part, but we need the IoT devices to collect that data. And once we have those coming out from the sensors of our connected cars, that can help us to bridge any accidents that will be happening. So IoT can help us, and all that monitoring can help us to even save lives. And that is for us, our users. But if you talk about mission critical applications like mining or oil and gas, or even remote corners of the world where there would be, where our workers are working in mines, and anything happens, it becomes really difficult to find out, like worker safety is a very big concern. But with the help of advent of IoT in oil and gas industry and the mining, we can curate the conditions which are there inside those areas, and workers' safety can be highly taken into concern that if anything goes wrong. And another thing I would like to mention is the buzzword you hear about IoT, but that is majorly about preventive maintenance. So if any of the use case you will hear about it, preventive maintenance is something that you don't wait for the disaster to happen. You don't wait for your electric appliance to go down. You already know that this machine in my house is taking a lot of electricity. Something is going wrong, and that it's surely going to fail in some days or some more time. So you will already know that things are going wrong, because you will be able to monitor the devices whichever you are using with the help of Internet of Things, that is IoT. So preventive maintenance is something which can help us on the roads. Even if I talk about connected transportation, it's not only about the cars that we are driving. It's not only about autonomous cars. It's a complete smart transportation infrastructure. And that includes cars, your railways, your ports, maritime, aviation industry, everywhere. You start from somewhere, you are transporting, like we are not transporting, but anything is going over the supply chain or it is going over some logistics, everything can be monitored. It goes over the railways, it goes over the ports. IoT devices can help us to get that complete visibility of whatever is happening throughout our networks or throughout the infrastructure. So that's one of the takes that I wanted to put about predictive maintenance and visibility, how the data can be analyzed and actionable insights can be derived from that, whether through edge computing or cloud computing. So all these things work in unison. It's not just that you have IoT and then you are not then you are not computing, like having the calculations over that data to tell to the car driver that, okay, there's an obstacle just like few meters away from you. So IoT cannot do anything alone. It's the synergies and the coming together of all the different Industry 4.0 technologies that help us to gain a lot variety of use cases. So that was my take about IoT and smart grid, smart infrastructure.
Thanks, Richa, quite intriguing, in fact. So I'll, with this, invite Anurag, if I may, and the value extraction part with your background in blockchain and IoT as well. So, can you dwell further for us on that part?
Blockchain and IoT?
Yeah.
Hi. Thank you, Suman. See, let's not call it blockchain. It's actually decentralized ledger technology. There are a number of blockchains. Bitcoin happens to be one of the most popular blockchains, right? But all the blockchains, they use decentralized ledger technology, or DLT as we call it. So that is one of the things which I wanted to get out of the way, right? Now coming to the combination of blockchain and IoT, which I was asked, and how they are coming together, what are the benefits which blockchain can bring into the IoT. See, the greatest challenge for the adoption of IoT is the security part of it, right? Most of the devices and the sensors which we have in the IoT devices, mostly they are not owned by single organization. So, like if any hack happens, it's really like it's very difficult to pinpoint that where did that particular hack happen. And secondly, IoT devices, they are generating humongous amount of data. So when this kind of data is generated, it's like it's very difficult to find out the ownership of that particular data. These are the challenges what we are facing. Another very big thing out here in IoT devices is that all the data is stored centrally. It might be in the cloud, it might be in your local servers, wherever. To take an example, like suppose in a healthcare scenario, right? Like if some IoT device is collecting some patient information and sending it across to doctors for analysis, now all that particular data is being transferred over internet. And it can, there are chances that it can be hacked. The cybersecurity part of it comes into play. So this is where blockchain, this is where the role of blockchain comes into the picture. As you might all be aware that blockchain is basically distributed ledger in which data is not stored centrally. Data is being stored across different nodes of a blockchain, and like before adding any particular data, we need to have consensus mechanism between all the nodes, and then only a particular set of data can be added. So the entire blockchain is basically tamper-proof. That is the main that is the main part of it. And whatever goes into the blockchain stays in the blockchain, right? Like it's not possible to go back and change any kind of data. So the major benefits which it is bringing is trust. It is bringing in transparency. It is bringing in security. So the security part of which I was talking about, that is where blockchain can really help the IoT devices, because the data can be stored in a decentralized manner where it becomes very difficult to hack any kind of data. Like most of IoT sensors are being very commonly used in supply chain nowadays, in trucks, in automotive industry, all these cars and trucks, they have IoT sensors for tracking and tracing, right? So all of this data can be very easily stored over a blockchain so that that data which is out there, it is trustworthy. And only the people who have access to that particular smart contract will be able to access that particular data. Just the last point which I wanted to make out here is that the other problem which I see is part of the IoT is the scalability of data, right? As Suman was pointing out, we have around 20 billion IoT devices. So when once we have those amount of IoT devices, you can very well imagine that, I mean, the amount of storage which would be needed, and the amount of money which would be needed to basically ramp up the capacity of the servers to store that particular data. But since we have blockchain out here, it is pretty easy to store that particular data in a decentralized manner. In fact, blockchain and IoT, Internet of Things, are beautifully coming together in the industry nowadays. And the industry has already coined a word for it, which is being called blockchain of things. So this is not, I mean, like all these things are coming up, they would take time in getting, basically in getting to the masses. But there's a lot of things which is which are going in the background, and things would be very different maybe 3-4 years down the line. Thank you.
Thanks a lot. In fact, quite many questions were put to rest with your discourse here. Anurag has finished. Ishan, you have spent time with AI, and while you were introducing yourself, you were also speaking about quantum computing being an area of interest. So what are disruptions which you see which quantum computing will bring despite what AI is doing today?
Yep. I would like to add one of the lines by one of my professors. He said, like, be synced with the nature. Most of us would think in here that being into information technology takes us away from nature, from Mother Nature. But we are actually mimicking Mother Nature in a way. And we are trying to take from Mother Nature and reimburse those concepts in a way that will be fruitful to the society. For example, let's take neural networks. We are mimicking the real life neural networks and we are taking concepts from them. Let's jump into soft computing or genetic algorithms. In genetic algorithms, we are coming up with a concept known as mating and pooling. And they are also taken from real life concepts. Coming up to quantum computing, quanta is actually the smallest discrete unit in a particular system. Starting from quanta, like most of us would be aware of quanta, I guess, and most of us would be aware of photon. Even a little kid like that brings on something that even a little kid feels inspired whenever they see light. They don't know anything else apart from getting inspired from light and getting attracted towards light, which is still a part of curiosity around. Looking at all of these facts, we'll jump up to quantum computing and how it will resolve the present day problems to much effective manner. I hope like we all would enjoy this because we are going to take it in a storyline manner rather than a written tale or something like that. So quantum, quantum is actually the smallest discrete unit, as I said. And within quantum computers, there are various types of quantum computers as well, ranging from photonic quantum computers, ionic and trapped ion, neutral atom, superconducting quantum computers. Looking up at all of these together, there are various algorithms as well, such as, anyone in the audience who would like to share that? If anybody is into quantum? Yep, sure. That's great. So like you'll be aware of Grover's algorithm, I guess, and we may come up with the famous Shor's algorithm. Like that will be the best thing, I guess. Shor's algorithm is actually working upon factorization, and that is actually linked to crypto systems. We can deal a lot of things within the blockchain system with Shor's algorithm. There are many other algorithms as well, such as Dirk's algorithm. Many people might have heard about that. linking up all of this together, like the changes it will bring in the modern world, I would like to go with that line by Spider-Man. Let's make it a little bit fancy so that all of us would be like having that one, like that interactive and like joyful session. So with huge responsibilities and like with powers, we go hand to hand, as we much have seen in Spider-Man. Same thing I would love to say with quantum computing, genetic algorithm, and like I would say generative AI, as said today. It has been disrupted by human beings in my eyes because we have to know that technology to the perfect extent. Taking into a storyline manner, in the past days I would love to share my experiences, and through that we would jump into quantum. I've seen across generalized people who are actually using generative AI in the most useless manner, asking it to write poems and similar stuff for amusing people. I would say the same thing would go on with quantum, and that would be the worst thing and the worst case scenario we would use quantum technology with, because people are not aware of various types of quantum computer as of the present instance. There are various quantum computers in the present day. Apart from that, like if I would say like I like trapped ion, or like I would say I would, if I like any other type of quantum computer, one is like an initiative by QEra. So in that thing, like we are still focusing upon Julia, and we are leading on with neutral atom quantum computing. But people may use that thing in a very bad manner. So using things effectively is one of the most efficient and advantageous things in my eyes. And coming up with that, like as our esteemed member said, how, like what we see in the upcoming days, like half a decade from now, I would think if I would have the technology, I could even mimic any human being in here, taking their memories through quantum computing. For example, like, let's take you from the audience. How do you think, like, let's make it interactive. How do you think I could mimic you? There must be multifarious ways. Any ideas? Yep, like directly taking your memories and creating a copy of you. That's true, like that's possible through quantum computing and quantum genetic algorithms, and like we could take the memory sequence, and through quantum computational biology. For example, let's take into the way protein folding. We might be aware of that term. Those complex terms and those complex sequences can be easily solved with quantum computing. Or we may lead up with chirality, if anybody may know, into QCD, or maybe quantum chemical reactions. So quantum computing can effectively deal with data, make it effective, and make it optimized so that we can make a faster paced search. For example, if you want to search in the audience somebody in the orange or red, it will take some amount of time because we are searching that thing through human brain. That's why we need technology to make things enhanced at a faster pace, optimized, and better for searchability. We still have data structures, but they are not that much fast that we could do protein folding and similar stuff with them. Similarly, through AI, we can lead a big quantum annealing. Most of us may know about the local minima. Anybody in the audience who is into AI and know about local minima? Anyone? That's through quantum annealing, and that's how like I would love to end the session in a way that there are multifarious things in our quantum technology which are linked with AI, and not even with AI, but with archaeology, with computational biology, with chemistry. We can take toxicity of chemicals as well, and eventually like if we all may bind up together, maybe like we'll not lose any loved ones who are in our family. We could mimic their emotions, they could generate stuff in real time. For example, like if we'll take I'll just like to take 2 minutes more to come up with something interesting. For example, if we'll take our most honorable member of India, like whom sir has been awarded with, Dr. APJ Abdul Kalam. If we were fortunate enough, we could mimic them with their memories, and we could take their answers at the present moment. They have given us various things. We could also mimic Albert Einstein through their memories, taking that sequence into the action. And we could come up with those brilliant ideas, and we would never lose those brilliant minds. I hope like we could all come up on this journey together, and we could lead up with quantum computing, AI, merged together with multifarious spheres around. And yep, like let's go with movies alongside that as well. Anyway, like just 1 more minute, I would like to take up with this thing. I like to read things and make them up in an animated manner. So that's in the same way like I have learned about quantum physics, quanta, and if you want to join in, we can join in with Q cohort. Like that's one of the initiatives I have been up with, through which like I'm trying to teach the audience about quantum computing through stories and tales making quanta, which is the minimal discrete unit into multiple characters within animated characters. And I guess like we can make learning enjoyable. That's also the title of one of my papers, where we are trying to make learning pedagogy much more enjoyable, which is not boring, obviously, because we actually feel much bored when we are coding over Java or any other thing. The target which I'm trying to come up with through quantum computing, and like we all are trying to come up with, let's make education interesting and make it vast scale. Let's make it to in the right manner towards our children, towards underprivileged students, and towards every section of the society, so that we could come up with something new. And if we are even watching movies, we can watch them in an effective and efficacious manner. That's all. Thanks.
We already have a hand wave here.
Sure.
So, say for example, AI became sentinel after some years, and they wanted to marry another AI.
iRobot.
So, do you think they can marry, or their algorithms will never match?
Human brain is full of curiosities, and like it is full of answers. If humans can marry, I guess like robots, for whom we will be the next gods, the demigods, maybe the celestials, they would be able to marry as well, transmitting data through other channels.
Thanks.
So
You're welcome.
these conversations are reminding me of all the Marvel movies that I have watched. Quantum computing, quantum realm, Ant-Man. Then we talked about Spider-Man. Then we talked about robots getting married. So it was a fun discussion to have here.
Yeah, thanks everyone. I think I have a hand wave there. Any point you want to add?
No.
Because we just went with it till the stopwatch told us it's time. So we can take questions. I think.
That is the perfect answer. Actually, I would say like I would come with. That is lovely actually, because I want to link AI with quantum. That's really appreciable.
Thanks a lot. Any other questions?
We can come up with more questions. Come on.
Unless you want us to ask each other questions. So I think we are done for the time. It's well beyond the sunset problem now. Yeah. Thank you.
So thank
Thank
you
you.
for your insights, sir. And all the panelists, please stay back for the group photograph first, and then the certificate distribution. I request Mitali to come on the stage and distribute the certificate to the panelists. First we have Mr. Anurag Agrawal. Thank you, sir. Next we have Commander Suman Kumar Chakraborty. Come on. Are you all feeling sleepy now? For the lady in black, Richa, Daga. And the person who has discussed today robots, their marriage and their transmitting data, Ishan, Shivansh, Bangroo.